Did you know that you can compress data streams on the fly using JavaScript? Imagine you've got some text, and you want to shrink it down. Simply create a readable stream, and then let it flow through a compression stream with gzip. Voila, the text gets compressed. You can even collect these compressed chunks in an array. Each piece is a tiny representation of your original data. Neat, isn't it? This makes transferring data faster and more efficient. Now, let's save our compressed data to a file. Imagine we have a file stream, like a container waiting for data chunks. As these chunks come through our gzip compression stream, they're written into our file, piece by piece. See, we set up write and close methods. The write method handles each chunk, while close celebrates our success shouting file writing is complete. Once the pipe is done, a message pops up, giving us a high five saying, compressed file written successfully. And if something goes awry, an error will let us know. What if something goes wrong during compression? To safely handle it, we use try-catch blocks. Check out this code where I am intentionally using an invalid compression format. As expected, it throws a type error, and our catch block handles it gracefully, logging a clear error message. If a different type of error comes up, it's caught by the else block and reported. It's a clean way to manage errors without crashing our code. Handling large datasets? Watch how compression stream manages without crashing your app. This function creates a massive stream of random data. As it compresses the data using gzip, you'll notice how the memory use stays under control. That's because compression stream is designed to handle backpressure, ensuring data flows smoothly without overwhelming your system. And as each chunk gets compressed, we can monitor the size right in the console. Data efficiency at its best. Received compressed data? Let's decompress it. Imagine you've got a blob. It's like a digital balloon stuffed with compressed files. To turn that back into usable data, well, enlist the help of a decompression stream. Think of it as a tiny machine that carefully removes the digital wrapping. We route our blob through this machine, which works its magic to give us a brand new blob. Only this time it's decompressed. Pop it open, and voila, you've got your original data back, just like before it was squeezed into that tiny package. Decompression can also be streamed chunk by chunk. Imagine we have a puzzle broken into pieces, and as each piece arrives, we're able to put it in place. Similarly, we begin with a series of compressed data chunks, resembling puzzle pieces. By feeding them into a readable stream and funneling that through a decompression stream set for gzip, each chunk is unpacked right when it flows in. Watching this unfold, we see our data piecing itself back together, with every chunk revealing part of the original content, just like solving that puzzle bit by bit. Be sure to match your compression formats, or you'll get garbled data. Say you've taken some text and compressed it with gzip, but then you try to decompress it using deflate. That's like trying to open a soda with a key. You end up with a mess since the formats don't match. Always check that you're decompressing with the correct algorithm. Otherwise, you'll be scratching your head wondering why all you're getting is a puzzling error instead of your original data. Fetch API can work directly with compressed streams, too. Imagine you want to grab a file from a server, but it's all zipped up in gzip format. No sweat. You use fetch to get the file, ensure the response is good, then pass it through a decompression stream using gzip. It's like unwrapping a present. What you get is the original, uncompressed file content. Finally, you read it as text and log it out. It's that straightforward. If anything goes awry, you'll see an error in the console. Consider compression performance implications. Choosing between gzip and deflate formats affects the speed of your data processing. Gzip is robust, with headers and checksums, but can be slower. Deflate, being more barebones, might offer speedier compression and decompression. Check this out. Let's time how long it takes to compress our data using both formats. Watch the console. We start with gzip, and then we compare with deflate. By measuring, well, see which one triumphs in terms of performance for our specific use case. Save bandwidth by compressing files before uploading. Imagine you've got a hefty file to send over the internet. You select the file, which gets read as a stream, and then magic happens. It zips through a compression pipeline, squishing into a smaller packet right before it gets fired off to the server. And the best part? Once the server nods a got it back to us, we know it caught our compressed file toss, unpacked it, and checked its contents, all with a perfect landing. No wasted data, no long waits, just smooth, efficient uploading.